All right, welcome back. We're going to start lesson 3, which is on combining like terms. So we know what a term is. It is some sort of algebraic expression that has a coefficient, a variable, and an exponent. Let's just write an example of that down again. 3x squared. Okay, where 3 is the coefficient, x is the variable, and little 2 up there, that's our exponent. Okay. So, combining like terms is super simple as long as we have a good grasp on these parts of a term. For terms to be like terms, the two terms have to have the same variable and same degree. So, back up here, as long as whatever else I'm wanting to combine has an x squared, cool, they're like terms. Okay? Let's try a couple of these combining like terms examples. Let's take that 3x squared and a 4x squared. Now, if I said I had 3 cookies in one hand and 4 cookies in the other hand, I'd have 7 cookies. And really, I wouldn't have 7 cookies because I'd be eating them all. But here I've got 3x squareds, and over here I've got 4x squareds. In total, I have 7x squared. You just add the 3 and the 4. You add the coefficients. Now notice, the variable and the exponent did not change, okay? You've got 3x squared, 4x squared, that adds to 7x squared, okay? Let's try another one. Okay, we've got like terms, x to the 5th, x to the 5th. So just say 4 minus 3 is 1. We could call that 1x to the 5th or just x to the 5th. Now, in reality, 1x to the 5th, totally correct. You're not wrong for writing it. But on a multiple choice or something that has the answers already ready for you, you would not see that coefficient of 1. You would just see the x to the 5th, okay? Let's try another one. Do we have like terms? Yes, we do. M to the 3rd power, m to the 3rd power, m cubed. So just add 2 plus 7, the coefficient 2, plus the coefficient 7, gives us a coefficient of 9, m cubed. Hope we're feeling okay so far. Let's see if I can throw a little curveball here. Two x squared plus 5y squared. Okay, here's the thing. These guys, they're not like terms. They have the same exponent, so that would be good, but x and y, two different variables, not like terms. And weirdly enough, the answer, if I ask you to combine those like terms, I mean, 1, I'm not going to, but 2, the most simplified version of all of that is that. 2x squared and 5y squared is 2x squared plus 5y squared. Let's look at another one. Two x to the 5th plus 5x to the 5th minus 3x. So we've got two sets of terms here. We've got a 2x to the fifth and a 5x to the fifth. Those are like terms. I'm going to combine those. 2 plus 5 is 7. But this negative 3x, it doesn't have anything else that's a like term with just an x to the first power. So bring it on over. And that would be our answer. Okay. Another example. 5r plus 6 minus 10r. So 5r, that's an r to the first power. 6, that doesn't have a variable, and so that would be a different degree. Over here, 10r to the first power, just remember that that is positive 5r and negative 10r. When you combine those like terms, those are going to combine to negative 5r. Bring over the plus 6, and we're good. Even longer one. 2x plus x squared minus 3x plus 4x squared. So I've got multiple pairs of like terms here. I've got a 2x and a negative 3x. And I've got a 1x squared and a 4x squared. Now, we always want to write our answer in standard form, even if we're not directly asked to. It's just a really good habit of getting into. So whenever I kind of scan through this, just like in our previous lesson, I'm thinking, hey, x squared has a higher degree than x to the first power. So I'm going to combine these guys first. 1x squared and 4x squared adds to 5x squared. And then 2x and negative 3x, 2 plus negative 3, or 2 minus 3, that's just negative 1. So negative 1x. Or 5x squared minus x. Again, this is not wrong. This is not incorrect. You're just more likely to see this in a multiple choice. I just had to bite back that instinct to say, any questions, y'all? Because I'm sitting here in my basement talking to myself. Okay. Let's see. Anything else? Let's just try a couple more tricky ones. Okay, 5r to the fourth minus 6r squared plus 3r to the fourth minus 4 plus r squared minus 6. Okay, so I've got several pairs of like terms now. I've got 5r to the fourth and positive 3r to the fourth. There's no other r to the fourths. Then I've got negative 6r squared and positive 1r squared. And I've also got negative 4 and negative 6. So again, best practice is to put this in standard form. 5r to the fourth and 3r to the fourth, those are the highest degree terms. And so I'm going to go ahead and combine those. 5 plus 3 is 8. After that, I don't have any r to the thirds, so I'll skip down to the r to the seconds, or r squareds. Negative 6 and positive 1 are going to add to negative 5. So negative 5r squared comes next. And then I've got -4 and -6. Well, if I'm $4 in debt and then I get another $6 of debt, -4 and -6 are going to add to -10. So the answer is 8r to the 4th minus 5r squared minus 10. Okay, here are a lot of terms, and there's some like terms. I would like for you to take a couple of moments to combine those like terms and write this whole expression in standard form. Okay, so as I scan through this, I'm not going to color code this one. What I'm going to do is just kind of scan through and look for the highest degree term. So I've got n to the first power, to the fourth, to the second, to the first, to the fourth, to the third, to the first. Okay, of all of those exponents, I see some 4s. So positive n to the fourth, or positive 1 n to the fourth, and -5 n to the fourth. I'm going to go ahead and combine these two. One minus 5 is -4. And then I'm just going to cross them out. Okay, after degree 4 is going to come degree 3. So let me scan through here. That's not degree 3, that just has a coefficient of 3. So we're going to move on. And I've got an n to the third power here. Now, it's a 1 n to the third power, but there's no other n to the third powers. So I'm going to go ahead and just bring it on down. Okay, after degree 3 comes degree 2. So I've got this -3n squared. Make sure you keep the negative with it. There's no like terms to go with that, so just bring it on down. Okay, after that, degree 2, there's just degree 1. So 6n to the first power, 7n to the first power, and -3n to the first power. All three of those are like terms, so we're going to add all three coefficients together. 6 plus 7 is 13. 13 minus 3 is 10. So that's positive 10n. And that is our answer. So all this is a game of kind of sorting and organizing things based on the fact that they have to have the same letter and the same exponent. Same letter and same exponent. Once you can do that, you just add the coefficients, the big numbers up front, and you're good to go. All right, a couple of questions are going to pop up now. And I hope y'all have a great day. Let me know if you have any questions, and bye.